Hi everyone! Again, this is Teacher Marichu, and I'm here to discuss with you our learning activity for Math Box Grade 8, Quarter 1, Week 4, D. The objective is for the learner to perform operations on rational algebraic expressions, specifically on the division of fractions. Going over with the generalizations here. The quotient of two rational algebraic expressions is the product of the dividend and the reciprocal of the divisor. So denoted as A divided by B divided by C over D, and that is equal to A over B times the reciprocal of the denominator or the divisor. In this case, C over D will become D over C. And once we had this, we can proceed with the multiplication of fractions, wherein in the numerator of the final product, we have to multiply the numerator times another numerator here all over the denominator of the first factor times the denominator of the second factor. Reciprocal, or we call also multiplicative inverse, refers to a pair of numbers such that when multiplied together gives a product of 1. Finding the reciprocal is simply a matter of transposing the numerator and the denominator, or interchanging. The numerator will become the denominator and the denominator will become the numerator. So example 1 here is done for you. So with example 2, moving on to example 3, and then 4. You can explore examples 1 to 4, and you can pause or press pause in this video whenever possible if you want to explore the solutions. Moving on to the exercises number 1, direction, divide and express your answers in simplest form. So let's get started with number 1. 2x minus 5 all over x squared divided by 2x minus 5 all over 5x. Solution. We have here, I just copied the expression, then copy the numerator of the rational algebraic expression, then just annex the operation multiplication and the reciprocal of the divisor. In this case, 2x minus 5 all over 5x will become 5x all over 2x minus 5. Doing this will give us 5 over x. Why? We have to cancel out 2x minus 5 divided by 2x minus 5. That becomes 1. And we have here x in the numerator and x squared in the denominator. So we have to cancel 1x here. So that means we have final answer is 5x. For number 2, we have a squared minus b squared all over ab squared divided by ab plus b squared all over ab. Copying this expression in the solution, we have here, then we change from division to multiplication and writing ab as the numerator and ab plus b squared in the denominator, but in this case, we factor out the denominator, that becomes b times quantity a plus b. Factoring also the first expression here, we have the sum of the difference of two perfect squares. We have a plus b times quantity a minus b all over ab squared. Now every terms here are in factored form. Now we can already cancel out expressions such as a plus b over a plus b, that becomes 1. Then the b and the b will cancel out, that becomes 1. Then a and a becomes 1 also. What is left is a minus b all over b squared. This is now the final answer. For number 3, we have 2x squared plus 11x plus 5 all over 4x squared plus 4x plus 1 divided by 2x cubed plus 10x squared all over 4x squared. Copy pasting here in this solution, we have changing this divide symbol into a multiplication symbol, then factoring the numerator becomes 2x plus 1 times x plus 5. And factoring the denominator, here we have 2x plus 1 times quantity 2x plus 1. This is a perfect square trinomial. So we have to copy twice here. And in this case, we can cancel 2x plus 1 in the numerator and denominator. That becomes 1. And let's try to explore this one. For x cubed will be up there. I wrote here 4 times x squared times x. That is equivalent to 4x cubed also. And factoring out also the numerator here, which becomes the denominator here. The factors of this are 2x squared times quantity x plus 5. Then x plus 5 has a factor also above here, x plus 5. Then we have 4 divided by 2 becomes 2, and the x squared will cancel out, giving us the final answer as 2x all over 2x plus 1. This concludes our exercises. And we move on to the numeracy scale. In the numeracy scale, it highlights skip counting by multiples of 6, 7, 8, and 9. So we have here the answer. Let me just demonstrate one row here. In this case, let me demonstrate the multiples of 9. That means that 9 times 1 equals 9. 9 times 2 equals 18, and so on. So this becomes 27, 36, 45, 63, 54, 63. And this is supposed to be 72. Just correct it in your module. And 81 and 90. Same is true with multiples of 8, meaning 8 times 1, that means 8. Then you keep adding. Add plus 8, that becomes 16, and 16 is equal to 8 times 2, and so on and so forth. It says here, least common multiple. That means multiplying a whole number by 0, 1, 2, 3, 4, 5, and so on, so that the products are called multiples of a whole number. This is all for now. This is Teacher Marichu saying stay happy, healthy, and safe. God bless.